Okay, this lesson's on how to simplify rational expressions. A rational expression is basically like a fraction, so you pretty much have to treat them the exact same. So any of the fraction rules still apply. So basically what we're doing is reducing these fractions into lower terms. So when I reduce a fraction, I divide what I can from both the top and the bottom. And so I can divide both the top and the bottom of this fraction here by 2. So I have 3 times 2 on the top, and I have 5 times 2 on the bottom. Now they're both being divided by 2, so I can cancel them out, and I'm left with a reduced fraction of 3 over 5. What I did to the top, I had to do to the bottom, and I divided it out. So some other examples where you have some variables put in. 3a over 5a. I can divide both the top and the bottom by a. So my a's can cancel out, and in this case I'm just left with 3 over 5. I'm taking the same out of the top as I did the bottom. The next question, 8 over 10x, sorry. I have 8 and 10. Now I can divide both the top and the bottom by 2, and that will leave me with 4 over 5x. Now one thing in both these questions, these are fractions, and I don't know what the variables are, okay? They can be any value, but they can't be a value that leaves my fraction with some sort of number over 0 in the denominator, okay? So you maybe have something like 5 over 0. That is not okay in fractions, okay? You cannot have the denominator over 0 because technically that is equal to infinity. So that's a problem, okay? That's undefined. So what I have to do is I have to put something called a restriction on. 5 times x. Well, this all works as a fraction, 4 over 5x, except if x equals 0. So x is not allowed to equal 0. Because if x equaled 0, I would have 5 times 0, which is 0, and I'd have 4 over 0 as a fraction, which is not good. When I go back to my first question, 3a over 5a, if a equaled 0, I would have 5 times 0. That is not good. I cannot have my bottom go to 0. So I have to state a restriction saying that a is not allowed to equal 0. Each one of these rational expressions, I have to state a restriction. Restriction being whatever value would make my denominator go to 0, because I cannot have a denominator go to 0. Okay? So a couple more examples. I want to reduce this fraction, so I want to divide both the top and the bottom by the same amount. So my 8 and 12 can be reduced down, divide both by 4, so that can leave me with 2 over 3. And then when I'm dividing, I subtract the exponents. A squared divided by a, okay, that's just going to leave me with a to the power of 1. And a be on top. b4, subtract b6, subtracting exponents is going to give me b to the negative 2. Or I can also write it down as being b squared just on the bottom, because I had 2 more b's on the bottom than I did on the top. Okay, I have 2 more b's on the bottom than I did on top, so I'd have b squared left on the bottom when you're dividing them away. Now again, I got to state my restrictions. Are there any values that would make at any point my denominator go to 0, my bottom of my fraction go to 0? And up here, if I had a value of 0, the whole thing would equal 0. 12 times 0 times whatever b is, doesn't matter. Anything times 0 is 0. So a is not allowed to equal 0, because it make my bottom go to 0. Same as my b value. B can also not equal 0, because I'd have 0 to the exponent of 6, which would make the whole thing go to 0. The whole bottom go to 0. So I have my 2 restrictions. A cannot equal 0 and b cannot equal 0 in my reduced, as I simplified my rational expression. There are other times where you need to factor first. Okay? 3x squared plus 6x. X squared over x squared minus 4. Both the top and the bottom can be factored. On top, I have common factoring. I can take out a 3x, and that'll leave me with x plus 2. On the bottom, that is difference of squares, which is going to leave me with x plus 2 and x minus 2. Notice how they both have an x plus 2. Both the top and the bottom have an x plus 2. So they can be canceled out. And you're simply left with 3x over x minus 2 as your reduced rational expression. Now again, I need to state my restrictions. So are there any values that would make your denominator go to 0? So in the first equation, or sorry, and I can look back at the original factored one here. If x was positive 2, that would make this part of the fraction go to 0. So x is not allowed to equal positive 2. X plus 2, well, if x equaled negative 2, that would make this portion of it go to 0. So x cannot equal negative 2 as well. So those are my restrictions that I have to state. Any value that makes the denominator go to 0 is not allowed to happen. Those are your restrictions. Okay? So I have reduced it by canceling out what I can, or doing whatever I can to reduce my fraction, and I have to then state my restrictions. Okay? So a short little lesson on how to simplify rational expressions. Basically, you're putting it into lower terms. Thank you very much.